Hey guys, this is Thatcher and welcome to episode 7 of my DCTL tutorial series. In this episode, we're going to be making a contrast and split toning tool for scene linear images, and we're going to make it so that you can trial a lot of different split toning schemes in a very short time while you're doing look development. At the same time, we're going to be learning about how to use pointers within DCTLs. So the first step in making this tool will be to support the ability to do contrast and split toning. In order to do this in scene linear, we're going to be making use of the gamma function. In other words, raising the input code value to a specified power. And we're going to do this in a way that preserves middle gray. Split toning can be simply accomplished by applying a different amount of contrast to each of the three channels. So we'll provide a way in order to add contrast to the whole image and to provide slightly different contrast to each of the channels relative to that baseline. So as a quick review from lesson 6, we know that the gamma function is stationary, meaning that it doesn't move. The input and output are equivalent when the input is 0 and when the input is 1. You can try this by raising 0 or 1 to any power. In order to preserve mid-gray instead of the value 1, we're going to scale x so that mid-gray is scaled up to 1, raise it to a power, and then scale the result back down so that mid-gray is restored. Instead of just using a single value for gamma, we can have a different value of gamma for each channel. And that's how we're going to create the appearance of split toning. I don't want to take too much time to do this, so let's go ahead and start writing up this DCTL now. I'm going to go ahead and make a new file. And I've titled the file DCTL Tutorial 7 Random Split Tone. Next, we'll paste in our transform function. And for this DCTL, we can simply use the normal transform function that works on individual pixels. Let's go ahead and pseudocode out what we're going to be doing. We're going to start off by establishing our parameters. So the first one is going to be the gamma for all three channels. And then we're going to have the adjusted gamma for red, green, and blue. Okay, really quickly, we're going to first define a function that computes our contrast adjustment described here. Then, in our transform function, we're going to read the input color, apply our contrast function to each of the three channels, and then return the result. I'll go ahead and code this up, and you can follow along. We'll start with the parameters. I think what we'll do is we'll make it so that these three parameters, rather than directly controlling the gamma passed to the red channel or the green channel or the blue channel, we'll make these represent the difference between the gamma sent to the red channel and the overall global gamma. So I'll make these equal to 0, and then we'll make them in a range of, say, negative 0.5 to positive 0.5. And we can always adjust these later if we don't like these values. Next, I'll write out the transform function. And we first have to write out the contrast curve function. This reminds me now that we do need a mid-gray parameter. We could just define that statically as float mid-gray equals 0.18, but I think it might be cleaner to allow the user to choose their value of mid-gray. There we go, we have mid-gray now. And we'll use the powf function in order to do this power computation. All right, now let's apply our contrast curve to each of the 3 channels. For the red channel, I'm going to pass in a gamma of global gamma plus red gamma, like so. And we'll do something similar for green and blue. All right, let's bring this DCTL into Resolve and see how it works. I'll go ahead and open up Resolve now. So right now we're in Resolve, and I have a very simple node tree setup. We just have a transformation from zlog2, my source footage, to ACES AP0. So that is AP0 primaries and a linear tone curve. Then I have an output transform from ACES AP0 linear to Rec 709 gamma 2 4 so that you can properly see the image. And we're just going to go ahead and use the default DaVinci tone mapping mechanism. So let's apply our new DCTL and see if it works. So we can see right now that we've loaded up the DCTL and the contrast adjustment doesn't make a difference. You might not be seeing this on your machine. And what's going on here is in our logs, we see there's this complain note return value. I suspect what's going on here is that I have this comment that has the word return in all lowercase because I couldn't find any other problems with my code. So let's go ahead and capitalize this like I had it in all my other DCTLs and see if that solves the problem. We'll hit reload. And now we can see that the contrast adjustment does indeed work here. And if I set some contrast, and then the split toning also seems to work as well. To make this more clear, let's add a linear exposure chart, and we can see what we're doing here. When I change the contrast of the green channel, for example, it does indeed introduce a split toning. Now, I'd like to highlight that when we make these simple red channel adjustments, you can see that it does indeed modify other channels in the lower right. And that's because we have this transformation matrix where after making the adjustment in ACES AP0, it is transformed into Rec 709, and that's the total output we see here. If we were to just look at the linear version, we would indeed see that modifying just one channel does indeed only modify that channel. Now that was pretty simple, but let's make a random number generator that will choose our overall contrast as well as split toning scheme for us so that we can try a lot of different variations. Now, what is a random number generator? A random number generator is a function that takes in what's called a seed, and then it will spit out a number at uniform between 0 and 1. At the same time, updating the seed. So next time you call the function, it will spit out a different number. Now, to be honest with you guys, I don't really know enough about number theory to design my own random number generator, but that's okay because on Wikipedia, there are a lot of different random number generators with free source code that you can refer to. Here's a Wikipedia article, list of random number generators, and you can see there are plenty of options, of which I tend to enjoy using XOR shift simply because it is incredibly simple. It's literally only 3 or 4 lines of code. For this project, let's go ahead and use the 32-bit version of XOR shift. To walk you through this code, simply put, we have a state, and a state is represented by an unsigned 32-bit integer. At the beginning of the code, we're going to pull out the state. We'll then do these 3 very simple exclusive OR and bit shifting operations. And then we're going to return the result and update the state to be equal to the result. So the seed will be updated with the new random number that we generated. However, this here is an unsigned integer, so it is an integer between 0 and roughly 4 billion, whereas we would rather have a float that's between 0 and 1. So what we can do is we can take x and divide it by the largest value that a unsigned 32-bit integer can represent, and that'll give us our number that is uniformly at random between 0 and 1, given the state. I'll say Wikipedia uses the word state here, whereas I use the word seed. You'll see both in the literature. Now you'll notice there is a caveat to this. So this function, we want it to return a float between 0 and 1, but at the same time, we also want to modify the state or the seed that we provide to it. The function can only really return one thing, and it'd be pretty clunky to have it return some kind of struct and then pull out both the seed as well as the return value. So the way that this implementation handles that is they pass in the seed as a pointer, meaning it's simply an address of the seed that we're trying to modify. That way, this function can modify the seed as it is defined elsewhere and simultaneously choose to return some number. For those of you who have some familiarity with pointers and programming in C, I do have to highlight that there is a difference between how you write code with pointers in C and how you write it in DCTLs. In order to make your code compatible with both CUDA and Metal, being Windows like NVIDIA and Mac OS, the engineers at Blackmagic Design require that pointers are prefaced with this qualifier called private with 2 underscores on each side. So in C, you could see that if you were to define some function with an argument, and that argument, if it were a float pointer param, in DCTL, you would instead have to say it's a private float pointer param. Similarly, if we're declaring variables, for example, here I have in C a float pointer that is the address of this float called bar. In DCTL, we would have to declare foo with a private qualifier. And then whenever we typecast something in which the new type is a float pointer, we would have to use the private qualifier there as well. Admittedly, in this case, I don't think the cast is actually necessary, but I wanted to show you what the cast would look like. With all this information, let's try and update our DCTL. The first step I'm going to take is to write comments everywhere to indicate what I think we have to do next. Let's go ahead and start writing the code. We'll first make the parameter that allows the user to choose a random seed. I think this would be a great time to use an int slider. Next, let's write up our random number generator using the Wikipedia article as reference. The first thing we need to do is define our state. So fortunately, DCTLs support most of the features of C as a language. So we can simply define the state as an unsigned int. I'm going to use typedef as we did in one of the previous tutorials. Here I've defined rand state to refer to an unsigned int. Okay, my random number generator has the name randu for uniform, as in between 0 and 1. It's going to return a float, and we're going to use our rand state pointer as our parameter, using the private qualifier in order to make it work with DCTLs. Let's go ahead and write out the code. This first line here means that I'm dereferencing seed. So seed right now is an address of a rand state, i.e. an unsigned int somewhere else. And I'm going to read what that unsigned int is and assign it to x. Okay, so now we have toggled and updated many of the bits within x, so we can update the seed and also scale x to be between 0 and 1 and return that as a float. So now we have a little challenge. How do we actually get the maximum value that an unsigned int can be? Well, an unsigned int is maximally large when all the bits are set to 1. So all we have to do is generate 32 ones very easily. So I think we can just do that by taking 0, cast it as an unsigned int, rand state, and then we can simply subtract 1. Another option would be to just flip all the bits using the negation operator. So I think I might actually do that instead. All right, and then we just have to return out. Next up, we have to read the user's seed and then tweak each of the 3 gamma channels appropriately. Okay, so now we have established our seed, which we've defined by taking user seed, which is the parameter provided by the user. We've identified the address of that user seed, and we're saying that that address is pointing to a random state. At this point, we've written quite a lot of code using the seed and our private qualifier and whatnot. I think it's important to make sure that this code is actually working as we expect, just to be sure. So let's go ahead, and just for now, we're going to say output.x is equal to randu seed, and we'll do this for y and z. We'll comment out our contrast adjustment, and then see if this generates random colors as the user chooses different random seeds. I'm going to hit reload, and we see that as the seed changes, we get fairly random colors on the left side. I do see that in most cases, the red channel is always 0, so that's probably not ideal. That being said, I think we can resolve that by simply calling randu one more time. All right, now we see a wider range of random colors. Okay, so now that we're satisfied that randu does indeed return effectively a random number between 0 and 1, let's go ahead and apply that to each of our contrast adjustments. Let's get rid of these 3 placeholder lines that we have, and we'll want to augment the global plus channel gamma using the random number generator. So I've done the simplest thing and simply added on the random seed to our existing gammas. But this is going to be problematic because randu returns a number between 0 and 1. As we recall from the DCTL, each of these contrast adjustments is somewhat more sensitive than that. Ideally, we'd probably only want to move the red contrast, green contrast, or blue contrast around by maybe 0.1 or 0.2 at most. So instead, we would probably like that our random number generator returns a number between negative 0.2 and positive 0.2. Let's go ahead and define another random number generator that, instead of returning a number between 0 and 1, instead returns a number between A and B. Now, I'm not going to rewrite all of this code. Instead, I'm just going to call our existing random number generator and then just scale its 0 to 1 output to be between A and B. Okay, that should do the trick. Let's go ahead and replace each of these randu calls with randu interval with a reasonably selected range. Or you know what? What would be even better would be to allow the user to choose what this range should be. So let's go ahead and define one more slider for the user here. And we'll go ahead and use this interval instead of negative 0.1 for these 3 spots. All right, let's see if our DCTL works now. All right, we can see on our test chart that there is some randomness going on. I'm disabling the test chart. We can see that there are indeed a variety of different split toning schemes being used. We can make the effect more extreme by dragging up the random interval. And we can see that while not all of these split toning schemes are good, it is perhaps a decent way to try out many different kinds of split toning in a short period of time. I think one last thing that would be nice to have would be a little checkbox so that you could turn on and off this random number generator. Let's hop back into VS Code and define that parameter. And then we'll simply check use random in order to determine whether or not we're going to use a random number generator or just the default rules. All right. And we do see that the DCTL works. I think one thing that might also be interesting would be if the global contrast could be adjusted via the random number generator as well. So we can simply update global gamma if use random is checked. And we'll just add on our global adjustment in each of these 3 spots. Let's see how that looks. There we go. So now it's both spitting out low contrast looks and slightly higher contrast looks. All right, that pretty much concludes episode 7 of my DCTL tutorial. In this tutorial, we covered making a contrast and split toning adjustment for linear state images, and then we incorporated a random number generator in which we made use of pointers using the private qualifier. We debugged our code and then made some quality of life improvements. Thanks for watching this video, and I'll see you guys in the next episode.